Linear inequalities. So linear inequalities are similar to linear equations, but they use an inequality symbol. And what an inequality symbol is it's either a less than, a greater than, a less than or equal to, or a greater than or equal to. You've probably seen these symbols throughout your math classes. Basically, this gives you lots of options for solutions, more than you would have had if it was just an equal sign. And so a solution to linear inequalities is any ordered pair xy, any coordinate that will satisfy the inequality. What it means to satisfy the inequality is basically it will make a true statement. So it makes it true. Makes it true. Now, graphically, we represent this with a shaded area and a solid line. That's how we represent solutions graphically. So before we start talking about the graphs, let's talk about actually the mathematical process of determining a solution. So determine which ordered pairs are solutions to the inequality represented by 2x minus 3y less than 15. And so what we're going to do is we're going to take the x value of the coordinate and the y value of the coordinate and substitute them into this inequality here. So we're going to have 2 times the x coordinate, which is actually a 2, minus 3 times the y coordinate, which is a 5, less than 15. So what we're going to do is we're going to simplify this to get a inequality statement at the bottom. So we're going to multiply 2 times 2, which makes 4. Then we're going to multiply negative 3 times 5, which makes negative 15, less than 15. Simplify here, so 4 minus 15 makes negative 11. And I'm going to see what I ended up with. If it's a true statement, then yes, the coordinate is a solution. If it's a false statement, then that coordinate is not a solution. So negative 11 is less than 15, so this is a true statement. So because this is true, that means yes, 2 comma 5 is a solution. Now, it's a solution, it's not the solution. And so linear inequalities have infinite number of solutions. So 2, 5 is just one of the possible solutions out there. Let's do one more together. So for letter B, again, we have a new coordinate. So the x is now negative 1, the y is now negative 7. Same inequality. So we're going to plug in what we have. So 2 times x, which is negative 1, minus 3 times y, which is negative 7, less than 15. And again, we're going to simplify. So 2 times negative 1 makes negative 2. Negative 3 times negative 7 makes a positive 21. And negative 2 plus 21 makes 19. So then we check, is 19 less than 15? Well, no. This is a false statement this time. And so because this is not true, 19 is not less than 15, that means that no, negative 1, negative 7 is not a solution. And again, it's not a solution, it's not the solution. Pause the video, try letter C and D. And here's what you should have had for letters C and D. Now let's look at what it means to have a solution graphically. So on the left, it says determine if each of the following ordered pairs are solutions to the linear inequality shown in the graph below. So there's nothing to substitute these x and y values into, but I do have a graph, so I can plot these coordinates. So for letter A, 2, 2, you're going to go right 2 and up 2. So there's letter A. And so from earlier, we said that this shaded area here, this is where you find solutions. That's why we have a shaded area. So because A is in the shaded area, yes, 2, 2 is a solution. Letter B says 0, 3. So over nothing and up 3. So letter B is barely outside the shade. And so since B is in that white space, it's not in the shaded area. No, 0, 3 is not a solution to whatever this linear inequality is. Letter C is 1, 1. Now here's a weird one. So 1, 1 lies on the line. Well, that could go either way because this is a boundary line. And so it's not really in the shade, but it's not really out of the shade either. It's right on the boundary. So because it is a solid line, it is a solution. Solid lines represent solutions. And so because 1, 1 is lying on a solid line, then yes, this is a solution. And finally, letter D is -1, 2. So left 1 up 2 is letter D, and that is outside the shade, so no, it is not a solution. So pause the video, try the next set. And here's what you should have had for your answers. Now, letter C is the weird one. So in math, we have to have a way to visually describe the differences between a solution and a non-solution. And so the way we do that is usually with darker things. So the darker things are the solutions, which is why we have a shaded area with solutions and a white space with non-solutions. Now, as far as a line is concerned, I can't make a line shaded. And so we have solid lines for solutions, and the way we represent non-solutions with lines is this open dashed line here. So that's the non-solution line. So if you see a dashed line and you land on the border, that is not considered a solution. So that's why letter C is not a solution, because it lies on a dashed line. So dashed lines are not solutions. Now let's talk about actually graphing these ourselves. And so first, before we go into the graphing, let's talk about the symbols. So a lot of this hangs on knowing what symbol is what word. And so this symbol here, we're going to talk about these. So this says y less than. And so this symbol is a less than. The second symbol is a less than or equal to. The third symbol is a greater than. And the final symbol is a greater than or equal to. And this will matter because it determines our line type. So first, let's write out all the line types. So for a less than, you have a dashed line. For less than or equal to, you have a solid line. For a greater than, you have a dashed line. And for greater than or equal to, you have a solid line. Now, pause the video and brainstorm. What do you think makes these the dashed and these the solid? Hopefully you had some ideas. So the solid line comes from the fact that it has this little bitty equal to underneath. So let's talk about just random examples. So let's say I had 2 less than or equal to 2. That's a true statement. And what makes it true is that little bitty equal to line underneath. If I had 2 less than 2, well, that's not true. So 2 less than 2 cannot be a solution, which is why we represent this with a dashed line. And then since the equal to's are allowed to be solutions with itself, that's where the solid line comes from. So if you have an equal to, even if it's greater than, so for example, 2 greater than or equal to 2, this little equal to makes this true. So we have a solid line. If you just had 2 greater than 2, that's not a true statement, and so it's a dashed line. So the equal to's on the symbol is what creates solid lines. Now the last thing we need is the shading direction. Well, if I have y less than, then that means the shading direction will be below my line. Again, even the second one is still a less than. Yes, it has the equal to, but it's still less than, and so this will also be below your line. Greater thans are above your line. You're going to shade above the line for greater thans and below the line for less thans. So now let's actually get into the process of graphing these ourselves. And so there's 3 main steps. So the first step is that the inequality must be in slope-intercept form. And if we can't remember what that is, it looks like y equals mx plus b. There's your slope-intercept form. We're not going to have an equals. It'll be something else like a less than or a greater than, but the y is by itself. Now here's the thing. If you have to put it in slope-intercept form, make sure to flip the inequality symbol if you divide by a negative number, just like you did before. So if you ever divide by a negative, your inequality will flip. So step 2, once you have it in slope-intercept, is to graph the line. You're going to use a solid line for less than or equal to or greater than or equal to symbols because they have that special equal to underneath them. We're going to use a dashed line for the less thans or the greater thans because they're those ones that are not equal. And then finally is the shaded area. We're going to shade above our line for greater than or equal to symbols. And we're going to shade below our line for less than or equal to. So let's look at example 1. So for example 1, we have y greater than or equal to 1/3 x plus 4. So step 1 has already been done for us. It's already in slope-intercept form. So now we just need to graph just like we would an equal sign. And so my slope is 1/3. My y-intercept is a 4. So always start by plotting your y-intercept on the y-axis, and then you're going to use your slope of rise of 1 and run of 3 to find more points. So from the y-intercept, go up 1 and right 3, plot a point. Up 1, right 3, plot a point. Now that I can't go up and right, go back to your y-intercept and move down and left. So down 1 and left 3 until you run out of room this direction as well. Now we have to decide the line type. So my symbol that I have is greater than or equal to, and that's from here. Well, because it has the equal to, it'll be a solid line through the points because it has that equal to. So we're going to connect our line with a solid line and put arrows at the end. And finally is the shading. Since it is a greater than, we are shading above the line. So the way I find above is hit the y-intercept and decide, well, if I want above my line, I'm going to move this direction. And so everything here above will be shaded. And so this is where you will find solutions. Now that's the next part. Find examples that are solutions and find examples that are not solutions. So any solution is anywhere in that shaded area. So I could pick this coordinate here, for example, as a possible solution. So this coordinate that I just put down would be -4, 4. I could also choose something on the line because it is a solid line, the thing on the line works. So 3, 5 is a good solution as well, but definitely in the shade is a solution. Now, non-solutions is basically anything outside of the shade and not on this solid line. So maybe like this, maybe 2, 1 is not a solution. Or maybe -2, -3 is not a solution. There's lots of possible answers for these. Okay, so I'd like you to pause the video and I would like you to try example 3. And here's what you should have had for example 3. So the special thing to remember about this one is that it is in fact a dashed line, which means the border is not solution. So this point here would not be a solution to this inequality. So let's look at example 2. What happens if the inequality is not in slope-intercept form? Well, we have to put it into slope-intercept form. So I'm going to have to take this inequality and solve it for y. So the first thing we're going to do is add 2x to both sides because I need to get y by itself. So we have -3y less than 2x plus 9. Divide out the -3 that's in front of the y. And now here's the trick. Because this was divided by a negative, because you divided by a negative number, that means you need to flip the inequality symbol. Flip the symbol in the middle. So this symbol here now turns over into a greater than. So this is still a y. And then negatives, we have -2/3x minus 3. So the key is that this inequality symbol flips over because we divided by a negative. Now when we're graphing, we actually use this to graph. So our slope is -2/3, pull the negative to the numerator. The y-intercept is -3. So we're going to start our graph at -3. Then we're going to move down 2 and right 3 to get some more points. Down 2, right 3, plot a point. Down 2, right 3, plot a point. Once you run out of room, go the other direction. Move up 2 and left 3. Up 2, left 3. Now let's decide. My symbol is now a greater than. Don't use this from the very beginning. Use the symbol from the slope-intercept form. So because it's greater than, the line will be dashed. So we're going to put a dashed line through these points, arrows at the end. And the shading is going to be above my line because it is a greater than symbol. And so we're shading above the y-intercept. So here is the solution. Now find some points that are our solution. So that could be anything in the shade. So 0, 0, for example, is a good solution. -2, 1 is a good solution. Anything in the shade will work as solutions. Now, the key here is anything on the line is not a solution because it is a dashed line and not a solid line. So for example, this border point here at -4, -1 is not a solution. Also, this point over here at -6, -4 is also not a solution because it's out of the shade. Pause the video, try example number 4. And here's what you should have had for example 4. The key to notice here is that this symbol did not change because all we divided by was a +3. So since we did not divide by a negative, the inequality symbol stays the same. Only when you divide by a negative does the inequality sign flip. So there's your number 4 solution.